When you strip away the comforting illusions of rocket nozzles and reaction mass, the most terrifying obstacle standing between humanity and the stars is not the cold vacuum of the void or the immense gulfs of interstellar space, but rather the stubborn biological reality of what we actually are. Because the universe does not merely resist our technology through friction and radiation, it actively rejects the fragile terrestrial architecture of our bodies and minds, forcing us to confront the unsettling truth that our anatomy, sculpted across nearly 4 billion years of evolution, specifically for this single blue world, breaks down the moment we attempt to truly leave it behind. Consider first the invisible tyranny of gravity, that constant downward pull of 9.8 meters per second squared that acts not merely as a preference, but as a fundamental structural requirement for every muscle fiber, a skeletal strut, and vascular pathway in the human body, a reality demonstrated daily by astronauts aboard the space station who, despite dedicating 2 hours every single day to grueling resistance and aerobic countermeasures, still suffer catastrophic losses in bone density and muscle mass over a mere 6-month rotation. While their cardiovascular systems, relieved of the burden of pushing blood upward against a terrestrial pull, undergo radical restructuring that shifts bodily fluids toward the head, swelling the optic nerve and permanently degrading vision through a baffling condition known as spaceflight-associated neuroocular syndrome, leaving researchers scrambling to understand a pathology that becomes infinitely more terrifying when projected across generations, as contemplated in the design of generational ships, where crews would live, reproduce, and die entirely within a metal cylinder, begging the profound and unanswered question of what a human skeleton, circulatory system, and optical network would look like after 4 or 5 generations spent swimming in perpetual microgravity. Yet gravity is only the opening salvo of a multifaceted assault, because the second invisible force waiting in the deep void beyond the heliosphere, that protective solar wind bubble stretching out to roughly 120 astronomical units, is unshielded cosmic radiation, consisting of high-energy protons, helium nuclei, and heavier atomic nuclei hurled across the galaxy by supernovae at significant fractions of the speed of light, particles that do not merely ionize cells like a routine medical X-ray, but instead shatter DNA strands entirely and pierce standard shielding materials to spawn secondary radiation that turns the hull itself into a toxic emitter, representing one of the top 3 existential hazards for a mission to Mars, which is practically next door in cosmic terms, proving that leaving Earth's magnetic field and its protective ocean of 10 tons of air per square meter exposes us to an unfiltered galactic fury that converts our very biology into a liability. Beyond these physical horrors lies an even more harrowing frontier, one that rarely appears on engineering blueprints or fuel calculations: the psychological collapse of a crew sealed inside a metallic tomb with no horizon, no familiar constellations, and no possible path back, plunging them into a mental wilderness where humans who are historically terrible at being confined together inevitably trigger the third quarter phenomenon, a well-documented psychological trough observed in submarines and Antarctic stations where morale, group cohesion, and emotional stability crater around the 75% mark of a mission, breeding petty irritations over eating habits and breathing rhythms that compound endlessly without the release valve of a simple walk outside. A baseline friction that becomes unimaginably amplified when scaled to decades or centuries, especially when combined with the crushing physics of communication lag, where a message sent to Proxima Centauri takes 4.2 years to arrive and another 4.2 years to return, creating an 8.4-year round trip for a single conversational exchange that transforms Earth from a living home into a distant mythology, a pale blue dot so utterly lost in the void that neither the sun nor the planet would even be visible to the naked eye from 40 trillion kilometers away, stripping away every physical anchor that has ever grounded human identity since the dawn of our species, from the scent of rain on soil to the familiar curve of a terrestrial horizon. This profound geographical and sensory severance births a radical psychological crisis, akin to an extreme cosmic solastalgia, a profound grief for a lost planetary home that forces us to question whether Homo sapiens as we currently exist are even the right biological species for the journey, or if survival demands deliberate, radical redesign through gene editing tools like CRISPR, first precision tested in human cells in 12, which now teeter on the edge of transforming our circadian rhythms, cellular radiation resistance, and neurological stress responses, raising the deeply unsettling philosophical dilemma that the entities who finally step foot on an alien world at the end of such a voyage will no longer be recognizably human in any traditional sense, having crossed a biological and neurological Rubicon to become something entirely post-human. Yet this internal landscape of isolation, generational drift, and identity crisis is mirrored and amplified by the staggering temporal scales of interstellar travel, where a journey to the nearest star at 1% of the speed of light requires 420 years, a span longer than the entire history of the United States, forcing us to grapple with a brain entirely unevolved to intuitively grasp deep time, leading directly to the immense crisis of motivational continuity on a generational vessel, where the founding generation is driven by the acute sacrificial memory of Earth, while their descendants, born into the ship without consent or context, may simply stop caring about a destination still centuries away, rendering the maintenance of purpose across deep time a social engineering challenge far more daunting than any propulsion physics. Much like the medieval cathedral builders of Europe who spent centuries constructing monuments like Notre Dame or Cologne Cathedral, projects taking up to 600 years, where the original stone layers never witnessed the finished spire, achieved endurance not through technical blueprints alone, but by embedding their work within a living, breathing cultural narrative, a deep time orientation that allowed them to sacrifice for people they would never meet, mirroring the exact psychological framework that a successful interstellar civilization would require. From parents planting trees they will never sit under to scientists pursuing truths they will never publish, reminding us that while the cosmos reveals our deepest biological and psychological vulnerabilities, it simultaneously offers an extraordinary invitation to expand our capacity for meaning, forcing us to decide whether the monumental leap to the stars is a tragedy of lost humanity or the magnificent, inevitable next chapter of our enduring story. And as that metallic vessel drifts deeper into the uncharted blackness of the interstellar medium, sliding silently past the invisible boundary of the heliosphere where the faint, dying whispers of our sun's solar wind finally surrender to the crushing, raw pressure of the interstellar wind, the inhabitants of this tiny floating world find themselves caught in a silent, unending psychological vertigo that no amount of engineering or technological preparation could ever fully insulate them against. Because when you remove the horizon, when you strip away the familiar cycle of sunrises and sunsets that has synchronized the metabolic and psychological rhythms of every terrestrial organism since the dawn of complex life, the internal clock of the human mind begins to drift into a strange, disquieting twilight, where days blur together into an undifferentiated monotony of humming air scrubbers and recycled water, a sensory deprivation so profound that it forces the psyche to turn inward, chewing obsessively on its own memories, magnifying minor interpersonal grievances into monumental betrayals, and breeding an acute, suffocating claustrophobia that permeates every square inch of the living quarters, turning the ship from a sanctuary of human ingenuity into an isolated psychological panopticon, where every sigh, every cough, every idiosyncratic mannerism of your fellow crewmates becomes an inescapable catalyst for tension, reminding us that humans are fundamentally social creatures engineered for the wide-open savanna, for tribal clans that could scatter and regroup under a shared sky, rather than for the sterile, unyielding geometry of a titanium tube hurtling through a vacuum, where a single catastrophic social fracture can spell the doom of the entire expedition. And this terrifying fragility of the social fabric is only exacerbated by the chilling realization that there is no cavalry coming to the rescue. No emergency extraction team flying out from Earth to pull a struggling crew back from the brink of a mental breakdown. Because once you cross that threshold into deep space, you are entirely on your own. a microscopic speck of organic warmth adrift in an ocean of unimaginable cold, forced to rely exclusively on a fragile ecosystem of closed-loop life support systems that must function flawlessly for decades, centuries, or millennia without a single major mechanical failure, a standard of perfection that no human-built machine has ever achieved over such vast spans of time, meaning that every breath you draw is mediated by pumps and filters that are constantly degrading, constantly marching toward an inevitable entropic collapse that mirrors the psychological decay ticking away inside the minds of the crew, creating a terrifying feedback loop where the mechanical anxiety of the ship's systems feeds directly into the emotional terror of the passengers, who watch the gauges with the quiet, suffocating dread of prisoners waiting for a trapdoor to spring, knowing that a single rogue solar flare, an unexpected collision with a high-velocity micrometeorite, or a localized mutiny born from the grinding despair of the third quarter phenomenon could instantly wipe out the entirety of human presence in this sector of the galaxy, reducing 4 billion years of planetary evolution, art, culture, science, and suffering to a silent, expanding cloud of organic debris drifting mindlessly toward nowhere. Which is precisely why the architects of any future interstellar endeavor must confront the most harrowing paradox of all, that the very technological prowess required to build a starship capable of crossing the interstellar gulf is utterly dwarfed by the moral, ethical, and existential catastrophe of deciding who gets to go, who gets left behind, and what right we have to shackle unborn generations to a metal prison cell driven by a planetary ambition they never consented to, transforming the entire enterprise from a glorious testament of human triumph into an ethical quagmire of cosmic proportions, where the ship becomes a floating, generational Noah's Ark, carrying not just the physical remnants of our species, but the crushing, inescapable weight of our collective existential baggage, our tribal animosities, our historical traumas, and our unyielding, terrifying hunger for meaning in a universe that remains profoundly, utterly indifferent to our existence, pushing us ever onward into the dark night of the deep cosmos, where every single mile we log away from our pale blue home demands an increasingly steep payment in the currency of our humanity, rewriting our flesh, our minds, and our very definition of what it means to be alive, until nothing remains of the terrestrial creature that first looked up at the stars and dreamed of touching them, save for an echo trapped inside the humming walls of a dying vessel screaming into the void. Let's begin with a confession that might feel strange coming from someone about to spend a very long time talking about the stars. The stars are not the problem. They never were. The problem is the space between them, and the problem is what happens to the thing that tries to cross that space. We like to imagine interstellar travel as the ultimate triumph of engineering. It's at the moment when humanity finally builds something fast enough and strong enough to leap across the cosmic ocean. But here is the uncomfortable truth that every serious researcher in this field has had to confront at some point. The engineering is the easy part. The physics is the easy part. The fuel, the propulsion, the shielding, the life support, all of that is solvable with enough time, enough money, and enough ingenuity. What is not solvable, what has never been solvable, what might never be solvable, is the simple biological fact that you are a creature made of meat and bone and water and electricity, and you were not designed for this. You were designed for a specific planet, a specific gravity, a specific atmosphere, a specific rhythm of day and night, a specific relationship with a specific sun. And the moment you leave that context, the moment you truly leave it, not just orbit it, not just visit its moon, but leave it, everything about you begins to unravel in ways that are fascinating, terrifying, and in some cases, completely irreversible. And the deeper you go, the further you travel, the more the terror compounds. Because interstellar travel is not a single challenge. It is a cascade of challenges, each one building on the last, each one more unsettling than the one before. And by the time you reach the end of that cascade, you are no longer asking questions about engines or trajectories. You are asking questions about what it means to be human at all. So let's start at the beginning, because the beginning is already bad enough. Let's talk about what happens to your body when you take it away from the only environment it has ever known. Your body is not a general purpose machine. It is a highly specialized instrument, exquisitely tuned over billions of years of evolution to function in one specific set of conditions. And the most fundamental of those conditions is gravity. Earth's gravity, 9.8 meters per second squared, is not a preference. It is not a convenience. It is a structural requirement. Every muscle fiber, every bone cell, every blood vessel, every neuron in your body has developed in constant dialogue with that number. Your skeleton is not just a framework. It is a load-bearing structure that has evolved to resist the constant downward pull of Earth's mass. Your muscles are not just engines. They are counterweights, constantly working against gravity to keep you upright, to move you forward, to pump blood against the pull of the planet. Your cardiovascular system is a sophisticated pressure management network that has evolved to push blood upward against gravity toward your brain and to regulate that flow with remarkable precision. And here's what happens when you remove that constant force. Your body, which is nothing if not adaptive, begins to remodel itself for the new conditions. And the new conditions are zero gravity. And zero gravity is, from your body's perspective, a catastrophe. On the International Space Station, astronauts who exercise rigorously for 2 hours every single day, who follow carefully designed resistance training protocols, who consume carefully calibrated nutrition, still lose significant bone density and muscle mass over the course of a 6-month mission. Their bones, which have spent their entire lives building and maintaining structure in response to gravity, suddenly have no load to bear, and so they begin to dissolve. Calcium leaches out of the skeleton, bones become brittle, muscles no longer needed to fight gravity begin to atrophy. The cardiovascular system, no longer struggling to push blood upward, begins to restructure itself. Fluid shifts toward the head. The optic nerve swells. Vision deteriorates. This condition, called spaceflight-associated neuroocular syndrome, or SANS, has been observed in a significant number of long-duration astronauts, and researchers are still working to understand exactly why it happens and how to stop it. And this is after 6 months. This is with constant communication with Earth, with carefully designed exercise regimens, with the knowledge that home is waiting. Now imagine not 6 months. Imagine not a year. Imagine generations. Because some proposed interstellar mission designs, the generational ship concept, involve crews who would be born, live their entire lives, and die aboard the vessel, with their children's children eventually arriving at the destination. What does a human being look like after 4 or 5 generations of low gravity? What does their skeleton look like, their cardiovascular system, their eyes? We genuinely do not know. And that uncertainty is not a small thing. That is one of the most profound open questions in the science of human space exploration. But gravity is just the beginning. The second force working against you silently, invisibly, relentlessly is cosmic radiation. On Earth, you are protected by 2 things: the planet's magnetic field, which deflects charged particles from the sun and beyond, and the atmosphere, roughly 10 tons of air per square meter, sitting above your head at all times, absorbing radiation before it reaches you. Out in deep space, beyond the heliosphere, the bubble of solar wind that our sun projects outward, stretching to about 120 astronomical units, there is no magnetic field protecting you. There is no atmosphere. There is nothing between you and the full unfiltered fury of galactic cosmic rays. These are not the radiation you think of when you think of a dental X-ray. These are high-energy particles, protons, helium nuclei, heavier atomic nuclei, traveling at a significant fraction of the speed of light, launched by supernovae and other violent events across the galaxy. When they pass through living tissue, they do not just ionize cells. They shatter DNA strands. They can pass through standard shielding materials and produce secondary radiation in the process, sometimes making the shielding itself a source of additional exposure. NASA has identified cosmic radiation as one of the top 3 risks to human health on a Mars mission. And Mars is, in cosmic terms, practically next door. You were built for Earth. 3.8 billion years of evolution went into making you perfectly suited for this world. And the moment you leave it, truly leave it, not just skim its upper atmosphere, your body begins to respond in ways that are fascinating, deeply concerning, and in some cases, irreversible. We have covered gravity, we have covered radiation, We have just scratched the surface. Because here's what I have not told you yet, and this might be the most unsettling part of all of this. The biological challenges of interstellar travel are almost manageable compared to what the psychological journey does to a person. And not just to one person, to a crew, to a community, to a civilization in miniature, sealed inside a metal tube with no way back, no horizon to look toward, no stars that look familiar anymore. What happens to the human mind when it loses its connection to everything it has ever known? That is what we will explore. And I promise you, it goes places you did not expect. Let us talk about something that does not get nearly enough attention in the conversation about interstellar travel. Something that does not show up in engineering diagrams or fuel calculations or spacecraft blueprints. Something invisible, unmeasurable in the traditional sense, and yet arguably the most decisive factor in whether a long-duration space mission succeeds or catastrophically falls apart. The human mind. Not the human brain as a biological organ, though we will get there, because what deep space does to the brain physically is its own kind of horror story. No, right now I want to talk about the mind. The part of you that needs meaning, the part that needs connection, the part that needs to feel on some fundamental level that what you are doing matters, and that the people around you are allies rather than threats. Because here is something that researchers in space psychology, yes, that is a real and growing field, have found consistently across decades of studying isolated, confined environments. Humans are extraordinarily bad at being alone together. Let me explain what I mean by that. When you put a small group of people in a confined space for an extended period of time, something predictable happens, not immediately. Usually not in the first few weeks when everything is novel and exciting and the mission feels electric with purpose. But slowly, quietly, the psychological landscape shifts. Small irritations that would be forgettable in a normal social environment. The way someone chews their food, the particular tone they use when they are stressed, the way they leave a shared space slightly messier than they found it, begin to accumulate without the release valve of being able to simply leave. Without the ability to take a walk and clear your head and come back when you are ready, these small frictions compound into something far more serious. Researchers call it the third quarter phenomenon. In long-duration isolated missions, whether in Antarctic research stations, submarine deployments, or space station rotations, there tends to be a marked dip in morale, group cohesion, and psychological well-being around the three-quarter mark of the mission. People become irritable, withdrawn, sometimes hostile. Sleep deteriorates, motivation drops. And this is in missions measured in months with regular communication from Earth with the knowledge that home is waiting. Now scale that to years, scale that to decades, scale that to generations. The longest continuous human spaceflight record belongs to Russian cosmonaut Oleg Kononenko, who as of early 2024 had spent more than 1,000 days in space across multiple missions. Over 1,000 days. And even with all of the psychological support, the regular video calls with family, the carefully structured schedules designed by teams of behavioral scientists, the psychological toll is real, documented, and taken extremely seriously by every space agency on the planet. On an interstellar mission, those support systems largely disappear. And here is why. And this is a physics problem that bleeds directly into a psychology problem. Communication delay. Right now, sending a signal to Mars takes anywhere from 3 to 22 minutes one way, depending on where the two planets are in their orbits. That means a conversation with someone on Mars is not a conversation at all. It is an exchange of recorded messages separated by gaps of 6 to 44 minutes between question and answer. That alone is psychologically taxing. Astronauts and mission planners have already flagged this as a serious concern for future Mars missions. But on a journey to Proxima Centauri, 4.2 light years away, a signal sent from the ship would take 4.2 years to reach Earth, and Earth's response would take another 4.2 years to come back. An 8.4-year round trip for a single exchange of information. Think about that for a moment. You ask a question. Your children will be several years older by the time you the answer, and by the time anything you said reaches home, the people you were talking to will have lived a significant portion of their lives since you hit send. At some point, and this is not a metaphor, this is a measurable psychological threshold, Earth stops being home and becomes something more like a mythology, a story, a place your grandparents came from, something you know intellectually but can no longer feel. And that severance, that loss of felt connection to the origin point, is something human psychology has never had to process before in the history of our species. Every migration in human history, no matter how vast, maintains some thread of connection. Even the most isolated prehistoric populations separated by oceans and mountain ranges and deserts were still on the same planet, still under the same stars, still breathing the same kind of air, still feeling the same gravitational pull, still oriented by the same sun. The disconnection of interstellar travel is categorically different from anything our ancestors ever faced. It is not just geographic separation. It is a fundamental severing from the context in which human psychology evolved. Think about what grounds you, what gives you a sense of continuity, of belonging, of identity. For most of human history, those anchors have been physical: the smell of rain on soil, the particular quality of light at a certain time of day, the sound of a language, a piece of music, a voice you have known your whole life, the visual horizon, that line where earth meets sky, that every human being who has ever lived has been able to look toward. On an interstellar ship, none of those anchors exist in their original form. They can be simulated. They can be recreated with extraordinary fidelity using technology we are already beginning to develop. But simulation is not the same as reality, and the human nervous system, built over billions of years to detect authenticity, knows the difference. There is a concept in psychology called solastalgia. It was coined by the philosopher Glenn Albrecht in 2003, and it refers to the distress caused by environmental change in one's home environment. It is the grief you feel when a landscape you love is altered, when the place that shaped you no longer looks or feels the way it did. People living through deforestation, desertification, or the flooding of coastal communities they grew up in report this feeling acutely. A kind of homesickness for a home that still technically exists but has become unrecognizable. Now imagine a version of solastalgia where the entire planet you evolved on is not just changed but gone, not destroyed, just so far away that it might as well not exist. A pale blue dot so distant it is not even visible as a separate point of light anymore. Carl Sagan's famous photograph taken by Voyager 1 in 1990 showed Earth as a mote of dust suspended in a sunbeam from a distance of roughly 6 billion kilometers. That image has moved people to tears for over 3 decades. It has reshaped the way entire generations think about our place in the universe. But Voyager 1 was only 6 billion kilometers away. Proxima Centauri is roughly 40 trillion kilometers away. From that distance, the sun itself, let alone the Earth, would be invisible to the naked eye. Our entire solar system would be indistinguishable from the surrounding stars. You would not be able to look out the window and find home. And here's where the psychological challenge becomes something almost philosophical. Because at some point during an interstellar journey, a question arises that no human being has ever had to answer in an experiential, lived sense. A question that our entire history, our entire mythology, our entire architecture of meaning has been built around avoiding. What are we if we are not from somewhere? Every culture on Earth is rooted in a place. Every religion, every origin story, every concept of identity ties humanity to this world. We are Earthlings. We are terrestrial beings. That is not just a biological fact. It is the deepest layer of our psychological identity. Strip it away, and you do not just have a person far from home. You have a person confronting an existential void that human thought has never fully prepared anyone to face. Some researchers believe that the first generation of true interstellar travelers, if they ever exist, will need to be not just physically exceptional and technically brilliant, but psychologically transformed in ways we do not yet fully understand. Not damaged, not diminished, expanded. They will need a relationship with identity and belonging that is fundamentally different from anything the rest of humanity has ever lived. And that raises a question that I find genuinely breathtaking in its scope. Is Homo sapiens, as we exist right now, even the right species for this journey? Because evolution does not work on the time scale of mission planning. Natural selection cannot be scheduled. But we are living in an era where the line between biological evolution and intentional redesign is beginning to blur in ways that would have seemed like science fiction even 20 years ago. CRISPR gene editing, first demonstrated with precision in human cells around 2012, and advancing at a pace that consistently surprises even the scientists developing it, has opened the door to deliberate modifications of the human genome. We are not talking about science fiction scenarios. We are talking about documented, peer-reviewed, real-world technology that is already being used to treat genetic diseases and is being studied for a vast range of applications. What if some of those applications included preparing the human body and the human mind for the specific demands of interstellar travel? What if you could reduce the body's dependence on the 24-hour circadian rhythm tied to Earth's day-night cycle? What if you could increase radiation resistance at the cellular level? What if you could alter the neurological architecture of stress response, so reducing the psychological impact of prolonged isolation and sensory monotony? These are not questions from the distant future. These are questions being asked right now in laboratories, in academic papers, and conversations at the intersection of astrobiology, genetics, neuroscience, and ethics. And the ethical dimension, the question of whether we should do these things, not just whether we can, is where the conversation gets truly deeply complicated. Because here is the thing that nobody talks about when they talk about genetically or neurologically modifying humans for space travel. The person who arrives at the destination would not be the same kind of person who left. Not just older, not just weathered by the journey. Fundamentally, biologically, neurologically different. Perhaps different enough that the word human, in its current biological and philosophical meaning, no longer fully applies. Is that a tragedy? An evolution? A necessary step in the long arc of our species' story? I do not think there is a clean answer to that. And I think the discomfort that question produces in most people, that instinctive resistance, that feeling of something being lost, is itself a deeply important data point. It tells us something about how tightly we hold the concept of what it means to be human and how much we fear losing it, even in the service of something as magnificent as reaching the stars. What we have just walked through is the psychological architecture of the problem. The inner landscape of what interstellar travel demands from the human mind and the ways our current psychology, brilliant and resilient as it is, may simply not be equipped for the journey as it stands. But here is what I want you to hold on to before we move to the next part. Every single one of the challenges we have discussed, the solastalgia, the social friction, the identity crisis of leaving Earth behind, the question of what it means to be human in deep space, every one of them is also an invitation to understand ourselves more deeply than we ever have before. Because space does not create these vulnerabilities, it reveals them. It strips away the comfortable noise of everyday life and shows us the architecture underneath. And what we find there, even when it is unsettling, even when it challenges everything we thought we knew about ourselves, is extraordinary. There is a thought experiment I want you to try. Not a complicated one, just a simple act of imagination that I think will reframe everything we are about to discuss in a way that no amount of data or scientific explanation can quite match on its own. Close your eyes for a moment. Actually, do not. You are reading this, but stay with me. Imagine you are born on a ship, not born into a family that boarded a ship, not born into a community that remembers boarding a ship. Born on a ship that has been traveling for so long that the concept of a planet, a real one, solid ground beneath your feet, open sky above your head, wind on your face, is something you have only ever encountered in old recordings, in stories your grandparents told, in a kind of cultural mythology that everyone aboard acknowledges intellectually, but nobody has ever felt. You have never stood on soil. You have never watched a sunset. You have never seen rain. Earth to you is not a memory. It is a legend. Now ask yourself, what does that do to a person? What does it do to a community? What does it do to the sense of purpose that holds a multi-generational mission together across centuries? Because this is not a hypothetical edge case in the conversation about interstellar travel. For any mission to even the nearest stars using propulsion technology anywhere close to what we can currently conceive of, generational ships are not just one option among many. For many proposed trajectories, they are the only option. And the human story that unfolds inside one of those ships across generations, across centuries, is something we have never had to think through carefully until now. Let us start with time itself, because I think we massively underestimate how strange our relationship with time already is, even before we send anyone to another star. The human brain is not built to process very large or very small timescales intuitively. We have a cognitive comfort zone, roughly the span of a human lifetime, maybe stretched a little in either direction by history books and family stories, and outside of that zone, our intuitions break down. We say we understand that the dinosaurs went extinct 66 million years ago, but we do not feel it the way we feel that last Tuesday happened 5 days ago. The numbers are real to us intellectually, emotionally, experientially, they are almost meaningless. This is not a flaw in human intelligence. It is a feature of a brain that evolved to solve problems on the timescale of a human life, in a social environment of a few dozen to a few hundred people, in a geographic range of maybe a few hundred kilometers. Our temporal intuition is exquisitely calibrated for that environment. It is almost comically mismatched for the timescales of interstellar travel. Consider a journey to Proxima Centauri at 1% of the speed of light, which is already enormously faster than anything we have ever built, would take roughly 420 years. 4 centuries. That is longer than the United States has existed as a country. Longer than the entire period from the first European contact with the Americas to the present day. Longer than the gap between Shakespeare writing Hamlet and the moment you are reading this. And Proxima Centauri is the closest star, the closest one, 4.2 light years away, in a galaxy that is 100,000 light years across, in a universe that is 93 billion light years in observable diameter. The numbers are almost obscene in their scale. And the human mind, your mind, my mind, the mind of the most brilliant astrophysicist alive today, cannot genuinely, viscerally process them. We can work them mathematically, we can plot them on logarithmic scales, but feel them, truly feel them? No, we are not built for that. And on an interstellar mission, that cognitive limitation becomes something with real, practical, devastating consequences. Here is one of the most profound and underappreciated problems of a generational ship mission: motivational continuity. When a mission launches, the founding generation had the people who actually board the ship and leave Earth behind have something extraordinarily powerful driving them. They have purpose. They have the weight of a historic decision. They have the emotional reality of what they left behind, the friends and family, the landscapes, the tastes and smells of a world they chose to give up. That sacrifice is enormous, and it generates an equally enormous sense of meaning. They know why they are doing this. They feel it in their bones. Their children, born on the ship, have a more complex relationship with that purpose. They were never given a choice. They did not volunteer for this mission. They were born into it the way any of us are born into the circumstances of our lives, without consent, without context, simply finding ourselves here and having to make sense of it. Some of them will embrace the mission with the same fire as the founders. Some will resent it. Some will grieve a home they never had. And some, and this is the one that keeps mission designers up at night, some will simply stop caring, because purpose is not automatically inherited, meaning does not pass through DNA. Each generation has to reconstruct it, reinvent it, choose it for themselves. And when the destination is a star that is still 300 years away, when nothing about your daily life has visibly changed in the direction of progress, when the stars outside the window look the same as they did when your great-great-grandparents were alive, maintaining the original fire of the mission across multiple generations is one of the most complex social engineering challenges our species has ever contemplated. Anthropologists and historians have actually studied this problem through the lens of existing long-duration cultural projects on Earth, and the findings are both illuminating and sobering. Medieval cathedrals are a fascinating case study. The great cathedrals of Europe, Notre Dame de Paris, Cologne Cathedral, Salisbury Cathedral, took generations to build. Notre Dame took roughly 200 years. Cologne Cathedral took over 600 years to complete, begun in 1248 and not finished until 1880. The people who laid the first stones never saw the finished structure. Neither did their children or their grandchildren. And yet the project continued. Generation after generation of builders committed their lives to completing something that had been started by people they never met, for reasons that had been articulated centuries before they were born. How? Why? Because those projects were embedded in a living culture, a religion, a community, a set of shared values and rituals and stories that continuously renewed the meaning of the work. The cathedral was not just a building, it was a statement about what the community believed, what they valued, what they thought the universe was about. And that statement was reinforced every single week in ceremonies and sermons and songs in a way that kept it emotionally alive across the centuries. An interstellar mission would need to do something equivalent. It would need a culture, not just a mission statement, not just a set of technical objectives, but a living, breathing, emotionally resonant, shared narrative that every generation could find themselves inside of. A story that made the work feel meaningful, not just to the person who started it, but to the person who would finish it 400 years later. Designing that culture intentionally, deliberately, in advance, with enough flexibility to adapt but enough stability to endure, is arguably the hardest problem on the entire list. Harder than propulsion. Harder than shielding. Harder than life support. Because you can test an engine, you can measure radiation, but you cannot simulate 400 years of human social dynamics in a controlled environment and see how it plays out. And there is another dimension to the time problem that gets almost no attention. And I find it one of the most quietly devastating aspects of the whole scenario. The people who arrive at the destination will not be the descendants of the mission. They will be something the mission produced, but never fully anticipated. They will be shaped by centuries of isolation, by the specific social dynamics of their ship, by whatever culture developed in that closed environment over 400 years. They will have their own customs, their own language drift, their own mythology, their own understanding of what Earth was and what the destination means. And when they arrive, if they arrive, they will look out at an alien star system, possibly with planets capable of supporting life, possibly with environments unlike anything in human experience. And they will have to make decisions, enormous decisions. Decisions about whether to land, how to land, what to do when they get there, how to organize a new society on a new world. Decisions that will affect not just themselves, but every generation that follows them. And they will make those decisions not with fresh eyes and the full context of human civilization behind them, but with whatever knowledge survived 400 years of transmission through an isolated community of a few thousand people in a ship in the dark. Think about how much information is lost in 400 years. Even in our connected, documented world, languages die. Scientific knowledge gets distorted through the telephone game of cultural transmission. Social structures evolve in unpredictable directions. Now, remove internet access. Remove contact with the broader flow of human civilization. Remove everything except what was loaded onto the ship at departure. And what arrives at the destination 4 centuries later might be something that looks human, speaks something resembling a language we would recognize, and carries the ghost of the original mission in its cultural DNA, but is also profoundly, irrevocably different from anything that departed. This is the point where time stops being a logistical problem and becomes something more like a philosophical one. Because what is the mission after 400 years? Who does it belong to? The people who launched it are long dead. Earth has moved on. 400 years of scientific advancement, political change, cultural evolution, possibly contact with the arriving ship's distant radio transmissions, but fundamentally separate. The crew who arrives at Proxima Centauri, or wherever the destination happens to be, are they completing humanity's mission? Or have they, through 4 centuries of isolated evolution, become something distinct enough that the mission is now theirs in a way the founders never quite intended? There is a famous philosophical puzzle called the Ship of Theseus. It asks, if you replace every single plank of a ship one by one until none of the original material remains, is it still the same ship? Philosophers have argued about this for centuries, and there is no clean consensus. But an interstellar generation ship takes this puzzle and applies it to something far more consequential than a vessel. It applies it to a people, to a culture, to a sense of shared identity and purpose stretched across centuries and light years. And at the far end of that journey, the question of what arrives and whether it is still recognizably us is one of the most profound that our species has ever had reason to ask. Now, here is where I want to introduce something that I think genuinely changes the texture of this conversation, because everything we have discussed so far, the loss of purpose, the generational drift, the philosophical question of identity across centuries, could sound like an argument against the whole enterprise, like a reason to stay home, to keep our ambitions within the solar system, where at least the light minutes are manageable and Earth is still a real, visible, felt presence in the sky. But I do not read it that way, and I do not think you should either, because here is what the science of isolated long-duration communities also reveals, alongside all the darkness and difficulty. Human beings are extraordinary at creating meaning in conditions that should, by any rational measure, produce despair. The cathedral builders of medieval Europe did not experience their work as a tragedy because they would never see it finished. Many of them experienced it as a profound privilege, to be part of something larger than themselves, something that would outlast them, something that connected them to a purpose that transcended any individual lifetime. There are communities today, indigenous cultures, certain religious traditions, certain scientific institutions that operate with what you might call a deep time orientation, a relationship with past and future that extends far beyond the individual lifespan, that situates the present moment within a story much longer than any single generation can witness. And research on these communities consistently shows that this orientation is not a source of grief or existential despair. It is a source of profound psychological stability, of meaning, of resilience. An interstellar civilization, if we ever build one, would need exactly this: a deep time consciousness, a willingness to act for outcomes you will never personally witness, to sacrifice for people you will never meet, to hold the thread of a story that began before you were born and will continue long after you are gone. And here's the stunning thing. Here's the part that I want you to sit with. We already do this. We do it imperfectly, inconsistently, often badly. But we do it every time a parent plants a tree they will never sit under. Every time a scientist publishes research they hope future generations will build on. Every time a teacher invests in a student whose full flowering they will never see. Every time a civilization decides to act on climate or biodiversity or the long-term health of its institutions with the needs of future generations in mind. We are already, in small and scattered ways, practicing the psychology of interstellar civilization. We just have not framed it that way. And that is the deepest terror and the deepest hope of interstellar travel, all wrapped into one. The terror is that we might not survive the journey as ourselves. The hope is that we might not need to, that the thing that makes us human is not the specific configuration of our bones and our genes and our neurons, but something more portable, something that can be carried across centuries and light years and passed from hand to hand, from generation to generation, like a flame. The terror is that the flame might go out. The hope is that it might burn brighter than it ever has before, in a form we cannot yet imagine, in a place we cannot yet reach, in a story we cannot yet tell. And that is the real reason interstellar travel gets more terrifying the further you go. Not because the distances are vast, though they are. Not because the physics is brutal, though it is. Not because the biology is unforgiving, though it is. But because every step deeper into the cosmos is also a step deeper into ourselves. And we have no idea what we will find there. We have no idea if we will recognize what we become. We have no idea if the people who arrive at the stars will still be us or something else entirely. Something that looks back at the pale blue dot and feels nothing. Or something that looks back and feels everything. Or something that has forgotten there was ever anything to look back at. And that uncertainty, that profound, irreducible uncertainty, is the most terrifying thing of all. Because it means that interstellar travel is not just just a journey through space. It is a journey through the unknown territory of what it means to be human. And no map exists for that. No engine can power it. No shield can protect it. It is a journey that every generation will have to make for itself, in the dark, with nothing but faith and story, and the stubborn human refusal to accept that the stars are beyond us. And maybe that is enough. Maybe that has always been enough. Maybe the cathedral builders knew something we are only beginning to rediscover, that the point of the journey is not to arrive, the point is to build something worth arriving in, to create meaning that can survive the crossing, to become the kind of people who can look at a star 4.2 light years away and say, we are coming, and we will be different when we get there, but we will still be us, or at least we will still be something we can be proud of. And that, in the end, is the most terrifying and the most beautiful thing about interstellar travel. It forces us to confront the question of who we are, not just as individuals, not just as a species, but as a story. A story that began on a small blue planet under a yellow sun in a quiet corner of an ordinary galaxy. A story that might end there, or a story that might spread across the cosmos, carried by creatures who are no longer quite us, but who carry our hopes, our dreams, our fears, our questions, our stubborn refusal to give up into the dark. And that story, whatever form it takes, whatever it becomes, will be the most human thing we ever create. Because it will be the thing we built when we had every reason to stay home, and we chose to leave anyway. Not because it was easy, not because it was safe, but because it was there. And because we are the kind of creatures who look at the stars and wonder, that restless, relentless, unquenchable wonder is the thing that will carry us across the void. Or it will be the thing that destroys us, or both, or neither. We do not know. And that is the point. That is always the point. The unknown is not something to be feared, it is something to be explored. And the greatest exploration we will ever undertake is not of the stars, but of ourselves. And interstellar travel in all its terror and all its glory is just the mirror we hold up to that truth. So look into that mirror. Look at the person staring back at you, the one with the fragile bones and the vulnerable DNA and the mind that cannot truly grasp the scale of the cosmos. And ask yourself, are you ready? Are you ready to leave everything you have ever known behind? Are you ready to become something you cannot yet imagine? Are you ready to carry the flame of humanity into the dark? And if the answer is no, that is okay. That is human too. But if the answer is yes, if even a small part of you says yes, then you understand something that most people never will. You understand that the journey is not about the destination. It is about what the journey makes of us. And that is the most terrifying and the most wonderful thing of all, because it means that the stars are not just out there, they are in here, in the human heart, in the human mind, in the human story. And that story is still being written, and we are the ones writing it. Every day, every choice. Every moment we choose to look up instead of down, every moment we choose to wonder instead of fear, every moment we choose to build something that will outlast us for people we will never meet in a future we will never see. That is the interstellar mission. That is the human mission. And it has already begun. It began the first time a human being looked at the night sky and asked, "What is out there?" And it will continue as long as there are human beings, or whatever we become, who are willing to ask that question and to answer it, not with certainty, not with safety, but with courage, with hope, with the stubborn, irrational, magnificent belief that the journey is worth it, that the crossing is worth it, that the becoming is worth it, and that in the end is the only answer that matters, the only answer that has ever mattered, the only answer that will ever matter, because the stars are waiting, and we are coming, and we will be different when we get there, but we will still be us, or at least we will still be something worth being. And that is enough. That has always been enough. That will always be enough. So go. Look at the stars, wonder, dream, build. And when the time comes, when the ship is ready, when the journey begins, step aboard, not because you know what awaits you, but because you are human. And this is what humans do. We go, we explore, we become, and we carry the flame. Always the flame. Into the dark, into the unknown, into the terrifying, beautiful, magnificent unknown. And that, my friends, is the most human thing of all. And that is where the true depth of this journey begins to reveal itself. Because the more we stare into the abyss of interstellar travel, the more we realize that the abyss is not out there in the cold dark between the stars, but in here, in the warm, wet machinery of our own skulls, in the fragile architecture of our own societies, in the trembling uncertainty of our own hearts. The terror of interstellar travel is not a single terror. It is a symphony of terrors, each instrument playing its own note of dread, each note building on the last, until the whole thing becomes a chord so complex and so dissonant that it threatens to overwhelm the very minds that are trying to comprehend it. And yet, and this is the paradox that sits at the heart of everything we are about to explore, it is precisely that terror, precisely that overwhelming complexity that makes the journey worth taking. Because the things that terrify us most are the things that teach us most about ourselves. And interstellar travel, more than any other endeavor in human history, is a mirror held up to the human condition. It shows us who we are, not as we wish to be, but as we actually are. Fragile, finite, frightened, and yet somehow still reaching, still striving, still refusing to accept that the stars are beyond us. Let us now descend into the next layer of this cosmic onion, because the layers just keep peeling back, and each one reveals something more unsettling than the last. We have talked about the body and what happens to it in zero gravity. We have talked about the mind and what happens to it in isolation. We have talked about time and what happens to purpose across generations. But there is a layer beneath all of those, a layer that we have only begun to glimpse, and it is perhaps the most terrifying of all. It is the layer of the self. The question of what happens to the individual human identity when it is removed from every context that has ever defined it. And I do not mean the psychological identity, the sense of self that we have already discussed. I mean something deeper, something more fundamental, something that operates below the level of conscious thought. I mean the biological self, the self that is made of trillions of cells, each one humming with the accumulated wisdom of 3.8 billion years of evolution. The self that is not just a mind floating in a body, but a body that is itself a kind of mind, a kind of knowing, a kind of memory. Your body remembers things that your conscious mind has never known. It remembers the rhythm of your mother's heartbeat, felt in the darkness of the womb. It remembers the first breath of air that filled your lungs, the first taste of milk, the first sensation of sunlight on skin. It remembers the particular quality of gravity on Earth, the way it pulls on every joint, every muscle, every organ, in a pattern that has been repeated for every human being who has ever lived, for every ancestor you have ever had, back to the very first creatures that crawled out of the primordial sea. Your body is not just a vehicle for your mind. It is a repository of ancestral memory. It is a living archive of everything that has come before you. And when you take that body out of the context that shaped it, when you remove it from the gravity, the atmosphere, the radiation environment, the day-night cycle, the seasonal rhythms, the microbial companions, the countless invisible relationships that your body has maintained with the living world for billions of years, something begins to happen. Something that we're only beginning to understand. The body begins to forget, not consciously, not in a way that you could articulate or even notice, but at the cellular level, at the molecular level, at the level of gene expression and epigenetic regulation, the body begins to lose its bearings. It begins to respond to the new environment in ways that are not adaptive, not healthy, not sustainable. It begins to remodel itself in ways that are, from the perspective of the organism, catastrophic. We have already talked about bone density and muscle mass in the cardiovascular system, but those are just the visible symptoms, the tip of the iceberg. Below the surface, there's a whole universe of biological disruption that we are only beginning to map. The microbiome, the trillions of bacteria and fungi and viruses that live in and on your body, that help you digest food, that regulate your immune system, that produce neurotransmitters that affect your mood and your cognition, that have co-evolved with you for millions of years, that are as much a part of you as your own cells. What happens to them in deep space? We do not know. We have barely begun to study the microbiome of astronauts on short-duration missions. The preliminary data is concerning. The microbial communities that live in the human gut, on the human skin, in the human mouth, shift in response to spaceflight. Some species decline, others proliferate. The delicate balance that has been maintained for millions of years begins to tip. And because the microbiome is intimately connected to the immune system, to metabolism, to brain function, these shifts could have consequences that we cannot yet predict. Then there is the immune system itself, the complex network of cells and molecules that protects you from pathogens, that identifies and destroys cancerous cells, that heals wounds and fights infections. The immune system is exquisitely sensitive to its environment. It is regulated by stress hormones, by circadian rhythms, by nutrition, by exercise, by social contact, by all the countless inputs that make up the fabric of daily life. In deep space, every one of those inputs is altered. The stress of isolation, the disruption of circadian rhythms, the altered nutrition, the reduced physical activity, the absence of the normal microbial companions, all of these factors converge on the immune system, and the results are not encouraging. Studies of astronauts on the International Space Station have shown that immune function is altered during spaceflight. Some aspects of the immune response are suppressed, others are dysregulated. The body becomes more susceptible to some infections and more prone to inappropriate inflammatory responses. And this is after 6 months in low Earth orbit, still protected by Earth's magnetic field, still in constant communication with mission control, still able to see the blue marble of home through the window. What happens to the immune system after years in deep space, beyond the protective bubble of the heliosphere, bombarded by galactic cosmic rays, isolated from every familiar biological cue? We do not know. And the not knowing is the terror, because the immune system is not just a defense mechanism. It is a sensing system. It is a way that the body knows itself and knows its environment. It is constantly making decisions about what is self and what is other, what is friend and what is foe, what is safe and what is dangerous. And when that system is disrupted, when it loses its bearings, the consequences can be profound. Autoimmune diseases, where the body attacks itself. Chronic inflammation, which is now understood to be a driver of nearly every major disease of aging. Allergic reactions to things that should be harmless. These are the potential outcomes of a dysregulated immune system. And in the closed environment of an interstellar ship where there is no escape, no external medical support, no way to introduce new biological diversity, these outcomes could cascade in ways that are difficult to even imagine. But the immune system is just one more layer. There is another layer beneath that, and it is perhaps the most fundamental of all. It is the layer of the genome itself. The DNA that is the blueprint of your body, the instruction manual that has been passed down with modifications from the very first life forms on Earth to you. DNA is often described as a stable, static molecule, the unchanging code of life. But that is a simplification. DNA is constantly being damaged and repaired. It is constantly being read and interpreted. It is constantly being modified by epigenetic marks, chemical tags that turn genes on and off in response to environmental signals. And it is constantly being bombarded by radiation, by toxins, by the countless insults of daily existence. On Earth, the DNA repair machinery is remarkably effective. It catches most errors, fixes most damage, keeps the genome largely intact across a lifetime. But in deep space, the balance shifts. The radiation environment is far more intense than anything on Earth. Galactic cosmic rays, high-energy particles from supernovae and other violent events can penetrate shielding and smash through DNA strands, causing double-strand breaks that are among the most dangerous forms of DNA damage. The repair machinery can fix these breaks, but the repairs are not always perfect. Errors accumulate. Mutations arise. Some of those mutations will be harmless. Some will be deleterious. Some, over time, could lead to cancer. And cancer in deep space, in a closed environment with limited medical resources, is not just a personal tragedy. It is a threat to the entire mission. But the genetic damage is not just about cancer. It is about the integrity of the germline, the cells that will give rise to the next generation. If the DNA in sperm and egg cells is damaged by cosmic radiation, the consequences could be passed on to children, and to their children, and to their children's children. The genetic heritage of the crew, accumulated over billions of years of evolution, could be progressively degraded over the course of a multi-generational mission. And this is not a hypothetical concern. Studies of astronauts have shown that spaceflight can cause changes in gene expression, in epigenetic marks, in the length of telomeres, the protective caps on the ends of chromosomes that are associated with aging. Some of these changes reverse after return to Earth, some do not. And the long-term consequences are unknown. So here we have a picture that is growing more complex and more terrifying with every layer we peel back. The body, the immune system, the genome, all of them are exquisitely adapted to Earth, and all of them begin to unravel when removed from Earth. But even this is not the whole story, because there is a layer that we have not yet fully explored, and it is perhaps the most unsettling of all. It is the layer of the brain itself, not the mind, not the psychological self, but the physical organ, the 3 pounds of electrochemical tissue that generates consciousness, that stores memory, that creates identity. What happens to the brain, the physical brain in deep space? We have already mentioned that the brain is affected by the fluid shifts that occur in zero gravity. The cerebrospinal fluid that bathes the brain, that cushions it, that removes waste products, shifts in response to the absence of gravity. The brain itself, which floats in this fluid, is affected. The optic nerve swells, vision deteriorates. This is the condition known as spaceflight-associated neuroocular syndrome, or SANS, and it is a serious concern for long-duration missions. But SANS is just the beginning. The brain is the most energy-hungry organ in the body. It consumes about 20% of the body's energy, despite being only about 2% of its mass. It requires a constant supply of oxygen and glucose delivered by a dense network of blood vessels. It is exquisitely sensitive to changes in blood flow, in oxygen levels, in glucose availability, in the chemical environment of the cerebrospinal fluid. And in deep space, all of these factors are altered. The cardiovascular system, no longer fighting gravity, begins to remodel itself. Blood flow to the brain changes, the distribution of cerebrospinal fluid changes, the pressure inside the skull changes, and the brain, which is remarkably plastic, which is constantly remodeling itself in response to experience, responds to these changes. But the response is not necessarily adaptive. The brain is not designed for zero gravity. It is designed for Earth. And when it is removed from Earth, it begins to change in ways that we do not fully understand. There is also the question of the blood-brain barrier, the protective layer that separates the brain from the rest of the body, that prevents toxins and pathogens from entering the delicate tissue of the central nervous system. The blood-brain barrier is regulated by a complex interplay of cells and molecules, and it is sensitive to inflammation, to stress, to radiation. In deep space, with the immune system dysregulated, with the body under constant stress, with cosmic radiation bombarding the tissue, the integrity of the blood-brain barrier could be compromised. And if the blood-brain barrier breaks down, the consequences could be severe. Neuroinflammation, cognitive decline, mood disorders, the whole cascade of neurological damage that we associate with aging and disease, accelerated by the unique environment of deep space. And then there is the question of neurogenesis, the creation of new neurons in the brain. For decades, scientists believed that the adult brain could not generate new neurons. We now know that it can, in specific regions, particularly the hippocampus, which is involved in memory and learning. Neurogenesis is regulated by a complex interplay of factors, including exercise, stress, sleep, and environmental enrichment. In deep space, all of these factors are altered. Exercise is possible but difficult. Stress is chronic. Sleep is disrupted. Environmental enrichment is limited by the confines of the ship. The result could be a suppression of neurogenesis, a decline in the brain's ability to form new memories, to learn new skills, to adapt to new situations. And for a crew that will need to learn, to adapt, to solve problems for years or decades or generations, that decline could be catastrophic. But the brain is not just a passive victim of its environment. It is also an active interpreter. It is constantly making sense of the world, constructing a model of reality that allows us to navigate our environment, to make decisions, to plan for the future. And in deep space, that model of reality is fundamentally altered. The sensory inputs are different. The visual environment is different. The sounds are different. The smells are different. The proprioceptive feedback, the sense of where your body is in space, is different. The brain, which evolved to make sense of a specific environment, is suddenly confronted with an environment that violates every expectation it has ever formed. And the brain responds by trying to make sense of it, by trying to construct a coherent model of this new reality. But the model is built on faulty data, on incomplete information, on sensory inputs that are fundamentally alien. And the result can be cognitive dissonance, perceptual distortions, hallucinations, a gradual erosion of the brain's ability to distinguish between what is real and what is not. This is not speculation, this is documented. Astronauts have reported visual illusions, auditory hallucinations, disturbances of the sense of time and space. The brain, confronted with an environment that does not match its expectations, begins to generate its own reality. And in the closed, monotonous environment of an interstellar ship, with no external reference points, no familiar landmarks, no way to ground the model of reality in external verification, the brain's construction of reality could drift further and further from anything we would recognize. This is the deepest terror of interstellar travel. Not that we will die, though we might. Not that we will suffer, though we will. But that we will lose our grip on reality itself. That the very organ that makes us human, that generates our consciousness, that creates our identity, that allows us to know ourselves and the world, will begin to unravel, to dissolve, to become something other than what it was. And the person who arrives at the destination, if anyone arrives at all, will not be the person who left. They will be something else. Something that looks human, that speaks human, that may even believe itself to be human, but that is fundamentally, irrevocably different. And that is the terror that lies at the heart of all the other terrors. The terror of losing ourselves. The terror of becoming something we do not recognize. The terror of discovering that the self, the thing we hold most dear, the thing we believe to be most real, is not a fixed entity, but a process, a fragile construction, a house of cards that can be blown over by the slightest cosmic wind. And yet, and this is the paradox that we keep returning to, it is precisely this fragility that makes us human. It is precisely this vulnerability that makes our achievements meaningful. It is precisely because we can lose ourselves that finding ourselves matters. It is precisely because the self is fragile that the act of maintaining it, of constructing it, of choosing it, is the most profound act of which we are capable. And interstellar travel, in all its terror, is the ultimate test of that act. It is the ultimate challenge to our ability to maintain ourselves, to construct ourselves, to choose ourselves in the face of an environment that is fundamentally hostile to everything we are. And if we can meet that challenge, if we can maintain our grip on reality, on identity, on self, across the vast distances and time scales of interstellar travel, then we will have achieved something truly extraordinary. We will have proven that the human spirit is not just a product of its environment, but something that can transcend its environment. We will have proven that we are not just creatures of Earth, but creatures of the cosmos, capable of carrying our humanity with us wherever we go. And that, in the end, is the hope that lies at the heart of the terror. The hope that we are more than our biology, the hope that we are more than our environment, the hope that we are more than the sum of our parts, the hope that the human story, the story of consciousness, the story of self, the story of meaning, can survive the crossing. The hope that we can become not just a single planet species, but a cosmic species, carrying the flame of consciousness into the dark. And that hope, fragile and trembling as it is worth all the terror. Because without hope, without the belief that the journey is worth taking, that the crossing is worth making, that the becoming is worth enduring, we are nothing. We are just meat and bone and water and electricity waiting to dissolve back into the cosmic dust from which we came. But with hope, with the belief that we can become something more, that we can carry our humanity across the void, we are everything. We are the universe becoming conscious of itself. We are the cosmos waking up. We are the stars looking at themselves and wondering. And that wonder, that restless, relentless, unquenchable wonder, is the thing that will carry us across the void, or it will be the thing that destroys us, or both, or neither. We do not know, and that is the point. That is always the point. The unknown is not something to be feared. It is something to be explored. And the greatest exploration we will ever undertake is not of the stars, but of ourselves. And interstellar travel, in all its terror and all its glory, is just the mirror we hold up to that truth. So look into that mirror. Look at the person staring back at you, the one with the fragile bones and the vulnerable DNA and the mind that cannot truly grasp the scale of the cosmos. And ask yourself, are you ready? Are you ready to leave everything you have ever known behind? Are you ready to become something you cannot yet imagine? Are you ready to carry the flame of humanity into the dark? And if the answer is no, that is okay. That is human too. But if the answer is yes, if even a small part of you says yes, then you understand something that most people never will. You understand that the journey is not about the destination. It is about what the journey makes of us. And that is the most terrifying and the most wonderful thing of all, because it means that the stars are not just out there. They are in here, in the human heart, in the human mind, in the human story. And that story is still being written, and we are the ones writing it. Every day, every choice, every moment we choose to look up instead of down. Every moment we choose to wonder instead of fear. Every moment we choose to build something that will outlast us for people we will never meet in a future we will never see. That is the interstellar mission. That is the human mission. And it has already begun. It began the first time a human being looked at the night sky and asked, "What is out there?" And it will continue as long as there are human beings, or whatever we become, who are willing to ask that question and to answer it, not with certainty, not with safety, but with courage, with hope, with the stubborn, irrational, magnificent belief that the journey is worth it, that the crossing is worth it, that the becoming is worth it. And that, in the end, is the only answer that matters, the only answer that has ever mattered, the only answer that will ever matter, because the stars are waiting, and we are coming, and we will be different when we get there, but we will still be us, or at least we will still be something worth being. And that is enough. That has always been enough. That will always be enough. So go, look at the stars, wonder, dream, build. And when the time comes, when the ship is ready, when the journey begins, step aboard, not because you know what awaits you, but because you are human. And this is what humans do. We go, we explore, we become, and we carry the flame, always the flame, into the dark, into the unknown, into the terrifying, beautiful, magnificent unknown. And that, my friends, is the most human thing of all. But wait, there is more. Because the journey does not end at the destination. It does not end when the ship arrives at Proxima Centauri, or wherever the destination happens to be. It does not end when the first generation born on the ship sets foot on an alien world. It does not end when the first colony is established, when the first crops are planted, when the first children are born under an alien sun. The journey continues. It continues because the challenges of interstellar travel do not stop at the destination. They transform. They evolve. They take on new forms. And the terror, the deep existential terror that we have been exploring, does not dissipate when the ship lands. It changes shape. It finds new expressions. It burrows into the new society that is being built on the new world. Consider what happens when the generational ship finally arrives at its destination. The crew, or rather the descendants of the crew, the people who have been born and lived and died on the ship for centuries, the people who have never known anything but the closed environment of the vessel, the people for whom Earth is a legend, a myth, a story told by their ancestors. These people are suddenly confronted with a new reality, a planet, a real planet, with real gravity, with real atmosphere, with real soil, with real sky, with real wind, with real rain, everything that their ancestors left behind. Everything has been preserved in recordings and stories and cultural memory is suddenly, viscerally, overwhelmingly present. And the experience is not what they expected. It is not what their ancestors expected. The planet is not Earth. It is not home. It is an alien world with its own gravity, its own atmosphere, its own biology, its own rhythms, its own dangers. The settlers, if they can be called that, are not arriving at a new home. They are arriving at a new world, a world that has never known human life, a world that has evolved its own ecosystems, its own chemistry, its own geology, a world that is fundamentally indifferent to the survival of these fragile creatures from another star. And the settlers shaped by centuries of life on the ship, shaped by the culture that developed in the closed environment of the vessel, shaped by the genetic and epigenetic changes that accumulated over generations, are not the people who left Earth. They are something new, something that has never existed before, something that is, in a very real sense, a new species, or at least a new subspecies, a new branch of the human family tree. And this new species, this new people, must now confront the challenge of building a new society on a new world. With no support from Earth, no contact with the broader flow of human civilization, no way to call for help, no way to go back. They are alone, truly, completely, irrevocably alone. And the terror of that aloneness, the terror of being the only humans in a vast and indifferent universe, the terror of knowing that everything they do, every choice they make, every success and every failure will be the foundation upon which all future generations of their people will be built. This terror is almost impossible to comprehend. And yet, they must face it. They must confront it. They must find a way to live with it, to work with it, to build something meaningful in the face of it, because they have no choice. They are here. This is their world now, and they must make it work, or they will die. And their deaths will not just be the deaths of individuals. They will be the deaths of a dream, the deaths of a mission that was launched centuries ago by people who believed with all their hearts that humanity could reach the stars. The deaths of a story that has been told for generations, a story of hope and courage and the indomitable human spirit, the deaths of everything that their ancestors sacrificed and suffered and died for. And so they must succeed. Not because success is guaranteed, not because success is even likely, but because the alternative is unthinkable, because the alternative is the end of the story. And the story, the human story, the story of consciousness, the story of hope, the story of the flame that has been carried across the void must not end. It cannot end, not here, not now, not after everything that has been sacrificed to bring it this far. And so they build shelters against the alien wind. They build farms to grow food in the alien soil. They build communities, societies, cultures, new ways of being human, adapted to the new world. They build schools and hospitals and libraries and laboratories. They build monuments to the ancestors who launched the mission, to the generations who kept the flame alive, to the dream that brought them here. And they build for the future, for their children, for their children's children, for the generations that will come after them, who will inherit this new world, who will continue the story, who will carry the flame forward into a future that they cannot imagine. And in the building, in the creating, in the becoming, they discover something that their ancestors knew, something that the cathedral builders of medieval Europe knew, something that every generation of humans has known in every corner of the earth since the beginning of time. They discover that meaning is not found, it is made. That purpose is not given, it is chosen. That hope is not a gift, it is a decision, and they decide. Every day, every moment, they decide to hope. Let us now turn our gaze toward a dimension of this journey that we have only hinted at, a dimension that lurks beneath the surface of every conversation about interstellar travel like a submerged iceberg waiting to tear the hull of our assumptions apart. I'm talking about the question of language itself, not the language of engineering or mathematics, but the living, breathing, evolving language that shapes how we think, how we feel, how we relate to one another, how we construct the very reality we inhabit. Every human being who has ever lived has been born into a linguistic world that was already there before them, a world of words and grammar and syntax that shapes the very structure of thought. The linguists and cognitive scientists who study the relationship between language and mind have long understood that language is not just a tool for communication. It is a framework for cognition. It shapes what we can think, what we can perceive, what we can imagine. The words we have available to us constrain the concepts we can form. The grammar we use structures the way we organize our experience of time and space and causality. And when you take a group of people and seal them in a metal tube for centuries, their language will not remain static. It will drift. It will evolve. It will change in ways that are unpredictable, uncontrollable, and potentially profound. We have documented examples of this phenomenon on Earth. Isolated communities, cut off from the broader flow of linguistic change, develop their own dialects, their own vocabularies, their own grammatical innovations. The English spoken in the 16th century is barely comprehensible to a modern speaker. The Latin spoken by the Romans evolved into the Romance languages: Italian, French, Spanish, Portuguese, Romanian, each one a distinct linguistic universe, each one shaped by centuries of isolation and contact and change. Now imagine this process accelerated and intensified by the unique conditions of an interstellar ship. A small population, perhaps a few thousand people, sealed in a closed environment for generations. No contact with the outside world, no new linguistic input, no pressure from other dialects or languages. The language of the ship will drift. New words will be coined to describe new experiences, new technologies, new social arrangements. Old words will fall out of use as the things they describe become irrelevant. Grammar will simplify in some ways and become more complex in others. Pronunciation will shift. And over the course of centuries, the language spoken on the ship will become increasingly distinct from the language spoken on Earth. At first, the differences will be minor. A few new words, a few changed pronunciations, a few grammatical quirks. But as the generations pass, the differences will accumulate. And at some point, a threshold will be crossed. The language of the ship will no longer be mutually intelligible with the language of Earth. The descendants of the original crew will not be able to understand the recordings left by their ancestors. The cultural heritage of the mission, the stories, the songs, the scientific knowledge, the philosophical insights, all of it will be locked in a linguistic code that the current generation can no longer decipher. And this is not just a practical problem, it is a profound existential problem, because language is not just a vehicle for culture. It is the medium through which culture exists. It is the fabric of shared meaning that holds a community together. When a language changes, the culture changes with it. When a language is lost, the culture is lost with it. And on an interstellar ship, the language will not be lost all at once. It will be transformed gradually, imperceptibly, over the course of generations. And the people undergoing this transformation will not notice it happening. They will not realize that they are becoming linguistically and culturally alienated from their own ancestors. They will simply speak the language they grew up with, the language of their parents and grandparents, the language that feels natural and familiar to them. And they will not understand why the old recordings sound so strange, why the old stories seem so distant, why the old songs evoke a sense of loss that they cannot quite name. This is the quiet terror of linguistic drift. It is a slow, inexorable process of alienation that operates below the threshold of conscious awareness. And it is one of the most powerful forces working against the continuity of an interstellar mission. But language is just one dimension of the cultural transformation that will occur on an interstellar ship. There is also the question of social structure, of the ways that human beings organize themselves into groups, hierarchies, institutions, and communities. Every human society that has ever existed has developed its own social structures, its own systems of governance, its own norms and values and expectations. And these structures are not arbitrary. They are adaptations to specific environmental conditions, specific historical circumstances, specific technological constraints. On an interstellar ship, all of those conditions are radically altered. The environment is closed and artificial. The population is small and isolated. The technological constraints are unique, and the social structures that emerge in this new environment will be shaped by these conditions in ways that we cannot predict. Will the ship society be democratic or authoritarian? Will it be egalitarian or hierarchical? Will it be collectivist or individualist? Will it be religious or secular? Will it be open or closed? These are not abstract questions. They are questions that will determine the fate of the mission. Because the social structure of the ship will shape everything else: the allocation of resources, the distribution of power, the resolution of conflicts, the motivation of the crew, the transmission of knowledge, the maintenance of purpose across generations. And the terrifying truth is that we have no idea what social structures will emerge in the closed, isolated, high-stakes environment of an interstellar ship. We have studied isolated communities on Earth, Antarctic research stations, submarine crews, space station rotations, but none of these are truly analogous. None of them involve the complete severance from Earth that an interstellar mission entails. None of them involve the multi-generational timescales that an interstellar mission requires. None of them involve the absolute finality of the departure, the knowledge that there is no going back, no rescue, no escape. And so we are navigating in the dark. We are making decisions about the social design of interstellar missions based on analogies that are imperfect, extrapolations that are uncertain, and intuitions that may be completely wrong. And the consequences of getting it wrong are not just the failure of a mission. They are the suffering and death of thousands of people, the loss of a dream that has been carried across centuries, the extinction of a branch of the human family that will never exist again. This is the weight of the responsibility that rests on the shoulders of anyone who contemplates designing an interstellar mission. And it is a weight that should give us pause. It should make us humble. It should make us cautious. But it should not make us give up. Because the alternative to trying is not safety. The alternative to trying is stagnation. The alternative to trying is the slow, quiet death of the human spirit, the gradual dimming of the flame of curiosity and wonder and ambition that has driven our species from the savannas of Africa to the shores of the cosmic ocean. And that death, that quiet extinction of the human spirit, is a fate far more terrifying than any risk that interstellar travel could possibly entail. So we must try, we must build, we must go. But we must go with our eyes open. We must go with humility. We must go with the understanding that we are not just launching a ship, we are launching a new branch of human civilization. We are launching a new chapter in the human story. And we must do everything in our power to ensure that the story we are launching is one that we can be proud of, one that our descendants, whoever they become, will be grateful for. One that will carry the flame of human consciousness, human creativity, human hope into the vast and beautiful darkness of the cosmos. And that brings us to another dimension of the journey that we have not yet fully explored, the dimension of ethics. The question of what we owe to the people who will be born on an interstellar ship, the people who will live and die without ever seeing Earth, the people who will inherit a mission they did not choose, a destiny they did not select, a burden they did not ask to bear. Is it ethical to launch a generational ship? Is it ethical to bring children into a world that is sealed inside a metal tube, a world with no open sky, no solid ground, no natural environment, a world that is entirely artificial, entirely constructed, entirely dependent on the continued functioning of life support systems that could fail at any moment? These are not hypothetical questions. They are questions that anyone who seriously contemplates interstellar travel must confront. And they are questions that do not have easy answers. On the one hand, there is a strong argument that it is unethical to subject future generations to the risks and deprivations of an interstellar journey without their consent. The children born on a generational ship will not have chosen to be born there. They will not have chosen to leave Earth. They will not have chosen to spend their lives in a confined artificial environment, far from everything that human beings have evolved to need and love. They will be, in a very real sense, prisoners of a decision made by their ancestors. And that seems deeply wrong. On the other hand, there is a strong argument that every human being who has ever lived has been born into circumstances they did not choose. None of us chose to be born. None of us chose our parents, our culture, our historical moment, our geographical location. We are all, in a sense, prisoners of decisions made by others. And yet, most of us find meaning and purpose in our lives. Most of us find ways to make our circumstances our own. Most of us find reasons to be grateful for the gift of existence, even when that gift comes wrapped in difficult and challenging conditions. And so the question becomes, is an interstellar ship fundamentally different from any other circumstances into which a human being might be born? Is it so radically alien, so profoundly deprived, so deeply unnatural, that it crosses a moral threshold beyond which we should not go? Or is it simply another set of circumstances, another set of challenges, another set of opportunities that human beings can adapt to and find meaning within? I do not have a clean answer to this question. I do not think anyone does. But I think it is a question that we must ask. And I think the asking of it, the wrestling with it, The refusal to accept easy answers is itself a sign of our humanity. It is a sign that we care about the people who will come after us. It is a sign that we take seriously the responsibility of creating the future. It is a sign that we understand the choices we make today will echo through the ages, shaping the lives of people we will never meet in ways we can never fully anticipate. And that brings us to yet another dimension of the journey, the dimension of technology. We have talked about the biological and psychological challenges of interstellar travel. We have talked about the social and cultural challenges. We have talked about the ethical challenges, but we have not yet fully explored the technological challenges, the challenges of building the machines and systems that will make interstellar travel possible. And these challenges are staggering. Consider the propulsion problem. To reach even the nearest star in a reasonable amount of time, we would need to travel at a significant fraction of the speed of light. And the energy required to accelerate a spacecraft to such speeds is almost incomprehensible. The kinetic energy of a spacecraft moving at 10% of the speed of light is enormous. It is the energy of a small nuclear weapon just for a modestly sized spacecraft, and to decelerate at the destination, you would need to expend an equal amount of energy. The fuel requirements are so vast that they strain the limits of what is physically possible. We have proposed various solutions to this problem: fusion rockets, antimatter engines, solar sails, laser propulsion. Each of these approaches has its own advantages and disadvantages. Each of them requires technologies that we do not yet possess. Each of them pushes the boundaries of what we know to be possible, and none of them has been demonstrated to work at the scale required for interstellar travel. But the propulsion problem is just the beginning. There is also the problem of shielding. The interstellar medium is not empty. It is filled with gas and dust, with charged particles and cosmic rays, with micrometeoroids and debris. At relativistic speeds, even a tiny grain of dust carries enormous kinetic energy. A collision with a grain of dust the size of a grain of sand could be catastrophic, and the radiation environment of deep space, as we have already discussed, is far more intense than anything on Earth. Shielding against this radiation is a formidable engineering challenge. The materials that would be most effective at absorbing radiation are heavy, and weight is at a premium on any interstellar mission. The materials that are light enough to be practical may not provide adequate protection. And the secondary radiation produced when cosmic rays interact with shielding materials can sometimes be worse than the primary radiation. Then there is the problem of life support, a closed ecological system that can sustain a human population for generations, recycling air and water and nutrients, producing food, managing waste. Maintaining a stable and habitable environment is a challenge that we have barely begun to address. The Biosphere 2 experiment in Arizona, which attempted to create a closed ecological system, was widely regarded as a failure. The system was unstable, oxygen levels dropped, carbon dioxide levels rose, species went extinct. The experiment had to be terminated early, and Biosphere 2 was on Earth, with sunlight and gravity and the ability to intervene from the outside. An interstellar ship would have none of those advantages. It would be completely isolated, completely self-contained, completely dependent on the continued functioning of its life support systems for the survival of its crew. And the consequences of a life support failure would be absolute. There would be no rescue. There would be no escape. There would be no second chance. The crew would die, and the mission would end, and the dream that had been carried across centuries would be extinguished in a single catastrophic moment. This is the technological terror of interstellar travel. It is not just that the challenges are difficult. It is that the consequences of failure are absolute. There is no margin for error. There is no room for mistakes. There is no opportunity to learn from failure and try again. Every system must work perfectly. Every component must function flawlessly. Every process must operate without interruption for centuries, for generations, for as long as the journey takes. And the probability that everything will work perfectly for that long in that environment is essentially zero. Something will fail. Something will break. Something will go wrong. And the question is not whether it will happen, but when and how, and whether the crew will be able to respond. This is why some researchers have argued that interstellar travel is not just an engineering challenge. It is a philosophical challenge. It is a challenge to our fundamental assumptions about what is possible, about what is achievable, about what it means to be human. Because the kind of interstellar travel that we are talking about, the kind that would take centuries and require generations of humans to live and die on a ship, is not just a matter of building better rockets. It is a matter of building a new kind of civilization. A civilization that is not rooted in a planet, but in a ship. A civilization that is not shaped by the rhythms of a natural world, but by the rhythms of a constructed one. A civilization that is not sustained by the resources of a planet, but by the resources it carries with it. A civilization that is, in every sense of the word, artificial. And the question is whether such a civilization is possible, whether human beings can thrive in such an environment, whether the human spirit can flourish in such conditions, whether the flame of consciousness, of creativity, of hope can be sustained across the vast distances and timescales of interstellar travel. And the answer, I believe, is that we do not know. We do not know because we have never tried. We do not know because we have never been forced to confront the limits of our own adaptability. We do not know because the challenges of interstellar travel are so far beyond anything we have ever attempted that we cannot even begin to imagine what the solutions might look like. But we do know that human beings are remarkable. We do know that human beings have adapted to every environment they have ever encountered, from the frozen wastes of the Arctic to the scorching deserts of the Sahara, from the depths of the ocean to the vacuum of space. We do know that human beings have built civilizations in the most unlikely places, that they have created meaning and beauty and purpose in the face of unimaginable hardship, that they have refused to give up, refused to give in, refused to accept that the darkness will win. And so I believe that if we ever do attempt interstellar travel, if we ever do build a generational ship and launch it toward the stars, the people who make that journey will find a way. They will adapt, they will innovate, they will create, they will build a civilization that is unlike anything that has ever existed before. A civilization that is shaped by the unique conditions of their journey, a civilization that will carry the flame of human consciousness into the vast and beautiful darkness of the cosmos. And they will do it not because they are superhuman, not because they are immune to the terrors that we have been exploring, but because they are human, because they carry within them the same spark that has driven our species from the beginning, the spark of curiosity, the spark of wonder, the spark of hope, the spark that says we can do this, we can go there, we can become something more. And that spark, that indomitable, unquenchable spark, is the most precious thing we have. It is the thing that makes us human. It is the thing that will carry us across the void. It is the thing that will ensure that the story does not end, that the flame does not go out, that the journey continues generation after generation into the infinite future. So let us embrace the terror, let us acknowledge the fear, let us confront the darkness, but let us also remember that we are the ones who carry the light. We are the ones who hold the flame. We are the ones who will decide whether the story continues. And we will decide to continue it. We will decide to go on. We will decide to build. We will decide to become. And that decision, made over and over by every generation in every corner of the cosmos, is the most human thing of all. It is the thing that defines us. It is the thing that will save us. It is the thing that will carry us to the stars. And when we get there, when we look back at the pale blue dot that was once our home, we will not feel sorrow. We will not feel regret. We will feel gratitude. Gratitude for the world that gave us birth. Gratitude for the ancestors who carried the flame. Gratitude for the journey that made us who we are. And we will look forward toward the new worlds that await us, toward the new stories that we will write, toward the new futures that we will create, and we will feel hope. Hope that the journey was worth it. Hope that the sacrifice was meaningful. Hope that the flame will burn forever. And that hope, that eternal, indomitable hope, is the answer to the terror. It is the response to the void. It is the defiance of the dark. It is the most human thing of all, and it will never die. It will never be extinguished. It will never be defeated, because it is who we are. It is what we do. It is the story we tell, and the story is not over. It is just beginning. The stars are waiting, and we are coming. And we will be different when we get there. But we will still be us, or at least we will still be something worth being. And that is enough. That has always been enough. That will always be enough. So go. Look at the stars. Wonder, dream, build. And when the time comes, when the ship is ready, when the journey begins, step aboard. Not because you know what awaits you, but because you are human. And this is what humans do. We go, we explore, we become, and we carry the flame. Always the flame. Into the dark, into the unknown, into the terrifying, beautiful, magnificent unknown. And that, my friends, is the most human thing of all.